Okay, so last video you watched how to dilate points. In this video we're going to talk about how to dilate shapes as a whole, about the origin. So anytime you're dilating something, you have to have a center of dilation. In 8th grade you're only going to learn about the center of dilation being the origin or the center of the graph. So to dilate a shape we also need a scale factor, and the scale factor tells us how to dilate. Is it going to get bigger? Is it going to get smaller? And if you notice, the scale factor, we denote that, or we call that K. And that's kind of, let me fix that a little bit. So we call that K. And K means the amount you are stretching or compressing the shape. Compressing just means to get smaller. So if K is greater than 1, that means the shape is going to get bigger, because you're timesing it by a factor, of integer factor. If K is less than 1, your shape will get smaller. So that's anything like 1/2, 1/4. You're making it smaller. You're making a fraction of what it used to be. If K equals 1, your shape will stay the same. So if you multiply anything by 1, it stays itself. That works just with shapes too. All right, so if we go to our first example, it says dilate DOG by a scale factor of 3. So my K value, that just stands for my scale factor, is 3, like they told us. And that means 3 is bigger than 1, so that means this is going to get bigger. Okay, so we have the points DOG listed here, so if you are following along with a graph and want to plot that on a graph, you can do that. Just pause the video and go ahead and plot them. Okay, so to dilate this, I always reference my dilations from the center. So the center is there. So I'm going to count the distance of each point from the center. So my distance from D to the center is 2 this way and 1 this way. So I have 2 and 1. So if you remember doing slope, you can kind of, it's kind of like the same movements. So we have over and we have a rise. So I'm going to multiply each of these numbers by our scale factor. So 2 times 1, or 2 times 3 is 6. So instead of going over 2, I'm now going to go over 6 from the origin. And 1 times 3 is 3, and I'm going to go down 3 from the origin. So I'm gonna go down 3, 1, 3, and I'm gonna go over 6. So this is gonna be my D prime point. So if you notice, I tripled each distance, the up distance and the side distance, to get my new point. So let's try O. So O's distance from the origin is 2 over and 1, 2 from the center. So 2 times 3 is 6, and 2 times 3 is 6. So I'm going up 6 and to the left 6. So from the origin I'm going to go 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So this is my O prime point. And last but not least, G. So to get to the origin, I can go up 1 and over 2. So 2 times 1 is 2, and 2 times 3 is 6. So now I'm going to double the distance. I'm going to go over 6 now, and down 2. Oh, sorry. 1 times 3. So this would be 3. So over 6 and down 3. And this would be my G prime. So notice my distance distance triples because I'm doing a scale factor of 3 from each point. So if I connect DOG, notice my triangle is indeed bigger. I dilated it bigger, it got bigger. So let's just list the points here. So that one was 1, 2, 3, 4, 5, 6, -6. Make sure you use parentheses. -3. O prime is -6. 1, 2, 3, 4, 5, 6. -6, +6. And G prime is 1, 2, 3, 4, 5, 6. -3. And that is how you dilate a shape bigger. So if I move on to my next shape, I'm dilating quadrilateral QUSE by a scale factor of 1/2. So my K value is 1/2, and because this number is less than 1, I'm getting smaller. So my shape should get smaller as I do this. So my center of dilation is always from the origin. So to get to the origin from C, we'll start at C. You have to go down 2 and over 1, 2, 3, 4. And over 4. So if I'm taking half of each distance, half of 2 is 1, and half of 4 is 2. So now I'm going to go from C, I'm going to go down 1 and over 2. So this is my new C prime. And so we'll do the same thing for you. Down 2 and over 4. So half of each of those values is 1 and this is 2. So now I'm going down 1 and over 2. So this is my U prime. All right, and then if we do S, so S is 1, 2, 3, 4, 5, 6 over, and 1, 2, 3, 4, 6 over and 6 up, so half of each of those values is 3. So I'm gonna go down 3 and over 3. This is my new S, S prime. And E is over 2 and up 6, so half of 2 is 1, half of 6 is 3, so I'm really going from the origin down 3 and over 1. And there's my E prime. So if you connect the dots, that was a bad line. I have a ruler. So if you see, this shape is indeed smaller than the one we started with. So we can go ahead and list those values. So I have -2, 1. U is 2, 1. E is -1, -3. And is 3, -3. One, 2, 3, -3. Yep. So that is how you dilate a shape smaller. So if you notice with both of our translations that we just did, our shapes change size. This is the only transformation that we will talk about that changes the size of the shape. So if you notice, this triangle obviously got bigger, and this quadrilateral obviously got smaller. So dilation is only one that will change the size of the shape that you're talking about. It will not change the orientation. So your E, S, C, and U all stayed in the same spot. They just got closer to the center. And D, O, G, they also got bigger, but the the letter position stayed the same. The triangle didn't rotate, it didn't move, it didn't flip. Our letters didn't flip. They all stayed the way they were. The only thing that changed was the size. And if you notice, the angle's a little small, or were the same too. So that is the video on dilating shapes.